Hi viewers, welcome to Lama Solution. Today we are going to see about different P&O MPPT for a solar PV system. Here we are going to discuss about 4 MPPT. So one is conventional P&O MPPT. So and then we want to discuss about the variable step size P&O MPPT. And then we want to discuss about improved variable step size P&O MPPT. And then finally you have to discuss about variable step size with the global scanning P&O MPPT, and then you have to combine the result of these 4 MPPT, and then finally you have to conclude the result whether which one provide better result than the other MPPT. So this detail you have to discuss in the video. So first you have to see the detail of conventional P&O MPPT. So here you will see that here we are using 250 watts panel and is going to be connected to the boost converter, and here we are using variable load. Okay, and then here you will see that so this is a conventional P&O MPPT. It going to be received to input PV voltage and current. Okay, so based upon PV voltage and current it will be generated duty cycle. So when you go inside that code of that P&O MPPT, so here you will understand the detail of that P&O MPPT. So here you have to initialize 4 parameter like initial duty cycle, maximum duty cycle, minimum and small change in duty cycle, and then here you have to initialize the previous instant voltage, power and duty cycle, and then here you have to initialize the value for that previous instant voltage, power and duty cycle, and here you have to calculate power of the PV, and then you have to calculate dV and dB, and then you have to check 4 condition. You have to check dB value whether it is greater than 0 or less than 0, and then you have to check the value of dV is whether greater than 0 or less than 0. Okay, so here you have to check 4 condition. If you consider dB, right, dB and dV. Okay, and dB having both are same sign, right, we need, so the duty cycle should be decreased in the conventional P&O MPPT. If both having similar sign, we need to decrement the duty cycle. Both having opposite sign, right, then we need to increment the duty cycle. So why we need to decrement and increment the duty cycle? That means, so when you go to check the PV characteristics, right, so here I'm going to now you check this one, right, so this IV PV characteristics of the PV array or PV panel. So now you consider 2 points. So these are the 2 points. So when you are taking a difference, for example, this is current instant, so this is previous instant. So when you take the difference, the sign will be negative, and this is current instant, this is a previous instant, and if you take the difference, then sign will be negative. So this is a peak point of the PV panel, right? So we need to operate that PV panel in this point. So this point known as peak power point. Okay, so but the system currently operated, that means PV system operated in this point only, so we need to just move this point towards this point, right? That means you need to increase the voltage. Okay, if both having a negative sign, then we need to increase the voltage. So here you consider, right, that PV is connected to the load via boost converter. In boost converter, when you have to increase the voltage, means we need to decrement the duty cycle. Okay, so for example, you consider this is the current instant, this is previous instant. So when you take the difference, the sign will be positive, and same case here the change in power sign will be positive. So for that condition also we need to move this point towards to this point. So here also we are going to increase the we need to increase the PV voltage in order to operate that PV array in the peak power point. Okay, so for that condition also we need to decrement the duty cycle, because we are increasing the voltage, then we need to decrement the duty cycle because we are using boost converter here. So the system operated in the left side, so this is a left side operation. In right side operation, both having different sign. Okay, when you consider 2 points, right, so this is the 2 points. If suppose you consider this is current instant, this is previous instant, you will take the difference, this will be minus. So this is current instant, this is a previous instant, then you will take the difference, the difference, then it will be positive. So both are having different sign. So but here you need to decrement the voltage, right? So here we need to decrement the voltage because PV operated in this point. So you have to make PV system at the peak power point level, right? Then we need to decrement the voltage. In boost converter, if you want to decrement the voltage, then you need to increment the duty cycle. Okay, so that is a concept. So based upon this condition only, we are making that P&O. That means we are writing code for that P&O MPPT. So that code only implemented here. Initially we are checking dB is negative or not. If dB is negative, we are going to check dB is negative or not. So if dB is negative, then we need to decrement the duty cycle, otherwise we need to increment the duty cycle. If dB is not negative, right, dB is positive, then you have to check dB is negative or not. If dB is negative, then we need to increment, otherwise we need to decrement. Okay, so this is a concept of P&O MPPT. So conventional MPPT. Okay, so next how we are going to improve the result of conventional P&O MPPT, right? So for that we go for variable step. Here you will see that, right, the del t, right, the del t will be constant. Okay, so here we are fixing value for del t. The del t is always constant in the conventional P&O MPPT. It won't going to be changed, right? So based upon this four condition, this value going to be added or decrement in the duty cycle. Okay, so this value won't going to be changed in the conventional P&O MPPT. So here that means in variable step size, right? Next we have to see about the variable step size P&O MPPT. In variable step size P&O MPPT, we are going to vary that the small change in that mean the del t value according with the condition. Okay, this value. So this value going to be changed according with the condition. So that is known as variable step size. Okay, so here that small change in duty cycle going to be variable. So that's why it is variable step size P&O MPPT. So I am going to open this code, right? So here you will see that we are fixing only D initial, D max, D minimum. We are not initialize that del t. Okay, del t here will be variable. Okay, and also you have to create that mean you have to make the del t is variable. So here you have to consider we are going to calculate so many parameter. That mean here we are passing three another two parameter thing with n and dd max. Okay, so based upon n and dd max, we are going to calculate the variable step size, right? Variable step value for that change in duty cycle. Okay, and then here the remaining thing will be same, right? So we are going to calculate that when we are going to initialize the V volt, I volt, P volt, D volt and M. So here we have introduce another parameter nothing but M. Okay, so based upon M only we are going to modify that small change in duty cycle. Okay, and here you have to fix the value for V volt, P volt, I volt and D volt, and then here we are calculating power, change in voltage, change in power, change in current, and then here we are going to calculate the ratio between dB and dV. So the ratio between dB and dV will be act as here. That means that only going to be vary according with the peak power tracking algorithm. Okay, so here the dB by dV nothing but we can call the slope of the PV characteristics. Okay, so next thing here we are going to check that value, right? The n value is less than dd max by m. So then you have to calculate the step value. Okay, step value is equal to n into m divided by I. So I nothing but current. Okay, and n nothing but variable, m is which is equal to absolute value of dB by dV. Okay, so based upon that you have to calculate the step value, and then here you will check the same condition, right? Whatever condition we checked for P&O MPPT, the same condition only we are going to apply. But here this variable, the step variable, right? So the step variable will be going to be vary according with the peak power point tracking concept. Okay, so this depends upon dB by dB. Okay, so that's why it is known as variable step size P&O MPPT. And also next we are going to move on to improve the variable step size P&O MPPT. So here we are using only one step, right? So here step 1 only varying. So we are using only one step variation. So here in improved variable step size P&O MPPT, we are going to use two variables, step 1 and step 2. So we are going to use two kind of varying step duty cycle. Okay, the remaining thing everything will be same. So here you will see that, right? So D initial, D max, D minimum as per that P&O MPPT, conventional P&O MPPT. But here you have to pass another two thing, A1, A2, right? In variable step size MPPT, we are passing N, DD max. So here you have to additionally N and DD max, you have to pass another variable A1 and A2. The remaining thing, that means we have to initialize V volt, I volt, P volt, D volt, and DM, and then we have to initialize the value for that V volt, P volt, I volt, D initial. That means D volt equal to D initial, and then you have to calculate P, dV, dP, di. Okay, by using this formula, and then you have to calculate this M equal to absolute value of dB by dV. And then you have to check as that means n is less than D max divided by M as per that variable step size P&O MPPT. And then here you have to calculate two angles. Step 1 equal to Nm A1 divided by I, step 2 equal to Nm A2 divided by I. Okay, but in variable step size we have to use only one formula. Step 1 equal to Nm divided by I, but here you have to use these two formula for calculating step 1 and step 2. So here you will see that, right? Here you have to add another condition, right? But in variable step size you have to follow as per that conventional MPPT, okay, conditions, right? But here that in improved variable step size you have to add this condition di value. Okay, so this will be comes from conventional, and here you have to add di, right? We are checking the di value whether it is positive or negative. So based upon that you have to add step 1 or step 2. If di is positive, right, you have to add you have to subtract step 1 or add the step 1. If d is less than 0, you have to add step 2 or subtract the step 2. So according with the condition of di, the remaining will be same as conventional P&O MPPT. Okay, so these are steps you have to include in the improved variable step size P&O MPPT. So next thing is we go with the variable step size global scanning P&O MPPT. So here that things everything will be same, right, as per that variable step size. Okay, concept. Only thing is, so here we are going to scan the power from the MPPT and power of the PV, right? And then you have to take subtraction, right, difference, and then it's going to be processed via absolute block, and then we have to check the value of that power difference, whether it is greater than 15 or less than 15. If it is greater than 15, so you provide the reset signal to that P&O MPPT for scanning the new global point, right? So that is called scope global scanning concept, right? That means we are checking the power difference between power from the P&O as well as PV power. If this power difference is more than 15, then we need to check for another global point from the PV array. So that is known as scanning, right? So we are including RS. The remaining thing, right? So here we are fixing and D initial, D max, T minimum, D delta T, and then here we have to initialize V volt, P volt, D volt, M and P MPP. So P MPP nothing but power of peak power, right, from that MPPT algorithm, and then you have to initialize that values, and then here you have to calculate the power dV, dP and M. So M we are considering here is absolute value of dB, and then here you have to check the condition that power of PV is less than PMP, then you have to check the V value. If value is less than V volt, then you have to decrement the duty cycle. That means, so here we are multiplying delta D with M, so that will be, then it will be act as a variable step size. If V is greater than V volt, then we have to increment the duty cycle. So same kind of the concept of conventional P&O MPPT, but so here we are using variable step size. And one more thing, here you have to check that RS value. If RS is greater than 1, that means the difference of power, right, it will be more than 15. So it will be reset the previous instant value. So what will be happen, right, when RS is greater than 0, the V volt, P volt and PMP will be 0. Then P&O MPPT, this MPPT variable step size P&O MPPT will be go for another round for scanning the new global point. Okay, so that is a concept of a variable step size with the global scanning in the P&O MPPT. So when you have to run this simulation, right, you can see the results here, right. So you will see this results for a conventional P&O MPPT. Okay. So this is a result of power and current of the conventional P&O MPPT. So here you will see that, right, current, power, voltage. So voltage, current and power. Okay, so this response we got it from that normal P&O MPPT. Okay, for changing load condition. So next I'm going to simulate variable step size. So this is a result we are getting for a variable step size P&O MPPT. Okay, so next move on to improve the variable step size. So this is a result of improved variable step size P&O MPPT. So next move on to variable step size global scanning P&O MPPT. So this is a result of variable step size global scanning P&O MPPT. Okay. So next already we compare the results. So and make it as document. So here you will see that, right, for constant irradiation and 25 degrees Celsius, load resistance at 30 ohms. So this is a result. So the PV power and the converter power. So here you will see that the blue color one is variable step size global scan, right, and pink color nothing but variable step size P&O, and black color is fixed step size P&O, that means conventional PO. So red color is improved variable step size P&O. So this from this result, right, you will see that, right, the variable step size global scan P&O MPPT will be provide better result than the others method, right. So here see that, right, the remaining having some initial oscillation everything, but the variable step size global scanning P&O MPPT will be provide better result than the other methods. Okay, and also here you will see that the comparisons. So variable step size global scanning P&O MPPT having the efficiency of 99.5%. Okay, and also the maximum power ratio, tracking ratio will be 99.68%. So the maximum power we are getting around 248.1 watts. Okay, so this is results, comparison results of this 4 MPPT. So from that we conclude that variable steps global scan P&O MPPT providing the better result than the other 3 MPPTs. So thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.